Hello, my name is Nancy Stolick and I'm the Education Manager at Friends of the Rappahannock. Today we're going to show you erosion boxes. So when we do erosion boxes, we see what happens with water as it runs across different surfaces, and these are replicating the watershed. So in this box, we just have a flat surface, a hard flat surface. This would replicate a parking lot, roads, and also the tops of all the buildings. This is impervious surface, so water does not soak in when it rains. It has to drain off somewhere. And on regular parts of the watershed, these type of areas drain off into storm drains, and then they flow into the river without any filtering. This next box over is an example of either a construction site or a farm or a garden. So it's loose soil, not held down by any roots. And again, this would go probably into the storm drains, and all of the sedimentation or whatever comes off here would go into local waterways. If this was an agricultural field, we can predict that there could be some manure being used as fertilizer or actually chemical fertilizer. If it was a construction site, there could be litter and also maybe gas and oil from the large machineries. And this box is representing a riparian buffer zone, which actually has not been touched much by humans. So these are modified landscapes from what is naturally occurring, and this is not modified. So this would pretty much be replicating what you see around us on the nature preserve here at Friends of the Rappahannock. There's a lot of root systems in here and holding the soil together. Okay, so on this one, there are many things we could find as pollutants, but the main ones we're going to find on parking lots and roads would be gas and oil. I'm going to put 2 drops on here. The other thing we'd find a lot in this area, in these types of surfaces, would be litter. So we're using sprinkles as litter. Just going to put a little bit on there. If this is a construction site, we could have litter. There's a little bit of litter there. If it was agricultural land, we could have manure. I'm gonna put some sprinkles on there. Also, construction site may have gas and oil, so I'm gonna put that on there. Just 2, the same as this one. Then, in a riparian buffer zone, we normally don't have any litter here because people either don't come in here or with it, or they pack it out when they leave, hopefully. But either way, we're gonna put a little bit of sprinkles in here just to show. There'll be animal waste in here, but again, this area, as we'll see with how the water runs off of it, handles that better than the other 2 areas. Now what we're gonna do to simulate rain across the watershed is we're gonna do about a 6-second rainstorm on each one of these. And I'm gonna try to do the rainstorm and hold the cup at the same time. 1, 2. Usually I'll have a child here holding the cup, so I'm gonna try to do both. We're looking at 3 things mostly. How fast does the water come off the surface? How much of it comes off the surface and into the jar from what I rained on the area, and what it looks like. 1, 2, 3, 4, 5, 6. The water started running off immediately. There was no lag time. Everything that was on the surface basically made its way into the jar. So the litter pieces and the food coloring, the litter pieces are the sprinkles, and the food coloring is representing petroleum products. And basically all of it came off. That's pretty much exactly what happens in our parking lots and roads. This is an agriculture field or construction site. Same thing, how much comes off, how quick does it come off, and what does it look like? 1, 2, 3, 4, 5, 6. No water has come out yet. Still no water. So this dirt was pretty dry because it's only been used one time. This is what we would expect to see in dry earth. It would hold a lot before it starts releasing its water. So I'm going to tip this a little bit so you can see maybe what the color is, if there's any on the bottom. It's a little bit coming out. I think I'm going to do a little bit more rain just so that you can see. Okay, so firstly, it took a lot longer to run out, unlike impervious surface. The dry earth soaked up much of the rainstorm before any came out. When I added extra, we did get a runoff to come off, but again, it doesn't really have the litter in it because the dirt held the litter, and it doesn't have the petroleum products, because those would probably sink in, but it does have sediment, which is exactly what would happen. So not as much because the earth is dry, and it's filled with sedimentation. So over here is our riparian buffer zone. We're going to do another 6 seconds here. 1, 2, 3, 4, 5, 6. No water has come off yet. Still no water. I'm going to do a little bit more just so, okay. A little bit of water is coming out now. So that took a long time, and I kind of added a little bit extra because I wanted you to see the color of this. But the root systems in here, just like the root systems in trees, the root systems in this grassy area, which represents the riparian buffer zone, holds in the dirt. So there is some water here because this box was just put together and not really connected sods yet, but you can see that it's much more clear than our dirt, our farmland or our construction area. And that's because the root systems of the plants are holding in the water and also filtering the water and keeping the dirt particles close to the roots. So again, this is erosion boxes, and this is showing you different surfaces. This is an example of a surface that humans have not touched much, and these two are surfaces that humans have manipulated in some way. Note that both of these would have to be attached to storm drain systems in order to accommodate for how humans have changed the landscape. In an area like this, a wooded area like this, nature is intact, and rainwater is handled by a function already provided by the roots in the systems of the trees and plants. So thank you very much.